Did you know you can use rechargeable lithium batteries instead of these standard AA's and AAA's? Here we have some AAA's from the dollar store. You can see right here it says 1.5 volts. AAA's and AA's, C batteries and D batteries are all 1.5 volts nominal voltage. That means that's approximately the maximum voltage that they will have when they're fully charged. In reality, they might go as high as 1.7 volts or somewhere around there and get down to about 1.1 volts as you use them. Why is that important? Well, say you're using a device like this. It's an electric shaver. It normally runs on 2 AA batteries wired in series. That means that the batteries are arranged like this. There's the button connecting to the side that doesn't have the button. Now there's not room inside this shaver for 2 AA's to be like that. So what they've done is they've made it go in a circle, a little loop like that. So normally you put your AA in negative to positive here, and then this metal strip takes the connection across, and then it goes negative to positive like that. So it accomplishes the same thing. Now you might notice something's going on in here. I have modified this so that this circuit is no longer in series but in parallel. That means the batteries are connected side by side like that. Positive goes to positive, negative goes to negative. A funny thing happens with batteries when you connect them these different ways. If they're connected like this in parallel, the voltage stays the same, but it effectively turns it into a bigger battery, one with more charge, more capacity, more runtime. If you connect them in series, the runtime stays the same, but the voltage adds up. So if you add these two together, it'll turn into 3 volts because they're both 1.5. They'll add together. If you put a third one on there, it'll go up to 4.5 volts. A fourth one, it'll go up to 6 volts, etc. I've tried a whole bunch of different electric shavers, and this is the one that has worked the best for me, even though it's just a $15 battery-powered travel shaver. This one is the smoothest and it cuts the best. So what I've done, and so I don't have to keep buying AA batteries constantly to get this thing to work, I decided to go with rechargeable lithium batteries. And the thing you have to know about lithium batteries, here's an example of a lithium battery. You can see it's 3.7 volts. So that's slightly higher than what it would be to connect 2 AA batteries in series. That would add up to 3 volts, maybe 3.4. So in order to use this, I needed to convert the circuit so that they're connected in parallel rather than series. Because if I connected 2 of these in series, we would be up at 7.4 volts. And this motor in here is not designed to run at that high voltage. It would be going way too fast and it would probably burn up eventually. So I converted it to parallel. All I did, you can see this used to be one solid strip of metal here. I just snipped it. I didn't need to snip it in both places, but I did just because of how I was doing this. So I broke that connection. So now this side is no longer connected to this side. But then I drilled some holes and I took some wire and I connected this metal strip here to here and this metal strip over here to here. So now the negative side from this side is connected to the negative side over here, and the positive side over here is connected to the positive side over here. And then I made this little reminder for myself so that I don't get confused years down the line and forget how to hook things up. Because if I hook the batteries up, if I insert the batteries incorrectly, if I put positive here, it's gonna be bad. They're gonna start discharging into one another, and they're going to get hot, and they might blow up. So don't try this at home, haha, but just kidding, you should, because it's really fun and cool. Anyway, so now the negatives are connected together and the positives are connected together, which basically makes my circuit like this. positives together, negatives together. And it works. Now the other thing I could have done, and what I originally did before I rewired it, is I used this battery. This is a AA sized lithium battery, 3.7 volts. And this is an old rechargeable AA that I've put tape on, foil tape, so this end is connected directly to this end. Basically, this is a dummy battery now. It doesn't have any of its own charge. It's just a connector. It's just a piece of metal, basically, that I'm sticking in here to make a circuit complete. So what I originally did is I would just have one lithium battery in here, and then I put a dummy battery in the other side, and then the shaver would run. The only issue with that is that now it has a lower capacity, so it wouldn't run for very long. So the only reason I modified this so I could put two in there is that it would run longer. It has a higher capacity, because when you connect batteries in parallel, you're essentially doubling the capacity. So you can see I'm inserting one battery in here, and it turns on. Normally you would need both batteries in there to complete the circuit, but since I've rewired it with the connection from here to here, you don't actually need two batteries in there anymore. Now I did the exact same thing with my Zoom G14. I didn't want to run it on AA's because it takes 4 of them and it would only last, I don't know, 12 hours of playtime maybe, and that could get expensive. So what I did, I got a bunch of lithium batteries in there. I gave myself a little bit of an instruction here. Don't let the copper wires touch. Okay, so this one I didn't do nearly as pretty of a job on. Basically, it was the same setup where you got your negative side here, and then it goes all the way around until the positive comes back home over here. So what I did is I got these copper wires, and initially, just like on the shaver, I wasn't doing the full circuit. I was doing just half of it. So what I did is I took this one here, this contact point here, and I took this copper wire and I stretched it out and put it to this contact point. So that's the negatives being connected together, and then I just put 2 batteries in like that. And that completes the circuit from negative back to positive. I clipped this part, all this metal stuff right here used to be connected together, and I cut it so that it's not anymore. I should say this device can be powered either by 4 AA batteries, which are connected in series, and that's a total of 6 volts nominal voltage, because it's 1.5 volt times 4, or it can run on a 9 volt DC adapter right here, or it can run on a DC 5 volt USB connector. So I knew that the operating voltage for this device is at minimum 5 volts and at maximum 9 volts. So based on just what I know about electricity, I knew I would be okay doing any voltage in between 5 and 9 volts. So when I finally decided to wire this up, I wasn't too concerned about the difference in voltage between lithium batteries and AA's. And what I ended up doing is setting this up so that it's 2 sets of 2 lithium batteries in series. One pair like that, and then the other pair go in the other direction. Like that, right? So I've got 7.4 volts this way, 7.4 volts this way, and then I connect these pairs in parallel so that it's still 7.4 volts, but now the capacity has been doubled because I have 2 pairs of this going on. That's exactly the way I have it wired up. It's just positive to positive, negative to negative, and then in between each point there's 2 batteries in series adding their voltage up to 7.4, which is a perfect little midway point between 5 volts and 9 volts. And I put these stickers in here. This is a torn up shipping label from UPS. I just use that to isolate the wiring from each other because I use these just bare copper wires. I didn't use insulated wiring in here because I thought it would take up too much space and not let the batteries sit in here flush. So I used these thin copper wires, and if they were touching, all hell would break loose. The batteries would be discharging super fast and they would be burning up the wiring in here. I actually did that a little bit by accident and melted some plastic right here. It's not good. You gotta not do that. So why would you want to use lithium batteries? Well, your phone uses a lithium battery. Tesla cars use lithium batteries. Basically, the advantage of a lithium battery over a more traditional rechargeable battery, NIMH or NiCad, is that either they don't have any or they don't have as strong of a memory effect. Classical wisdom with rechargeable batteries is that you need to discharge them fully and then recharge them fully, or else you will risk damaging the battery. Basically, as you use the battery, the part of the battery that you use gets worn out, meaning the charge level from 100%, if you drain it down to 90% and then recharge it, you're wearing out that piece of the capacity. It's kind of like a road. If you keep walking down the same road over and over, just part of it, you're going to wear out that part of the road. But if you walk down the entire road, then you're spacing out your wear and tear over the entire road, so the whole thing lasts longer. So on old rechargeable batteries, you notice that the capacity wears down over time. They don't hold charge nearly as well after years of use as they did when you first got them. And that can be a bummer. Whereas with lithium batteries, they don't seem to have that effect. Like, you can pull out your old cell phone. I can pull out my Nintendo DS from 2004 and turn it on, even though it hasn't been used in years, and the battery is still right where I left it. It's still charged. It does not wear out, you know. So there are different sizes of these lithium batteries. The AA ones are the 14500s. So if you want to get something that will fit in a AA battery slot, you need the 14500. You can find them in those red packages. You can also find them in these generic looking blue sleeves. They tend to be dishonest about the capacity rating of these. This says 2000 milliamps, which means, well, it means nothing to you if you don't know anything about electricity, but basically that's the capacity rating of this battery. I guarantee this is not a 2000 milliamp battery. It's probably more like 600 milliamp, but there's not very good regulation and standard for Chinese products to accurately represent themselves. But my phone that I'm recording this on has a 3000 milliamp battery, and I'm sure it's quite a bit larger and heavier than this little thing, so there's no way this is 2000. These red ones say they're 800. See, I believe that because that's a much more reasonable thing. And also, you can't get more capacity without making a bigger battery. So this blue one is just completely lying, but it's okay. And then you've got this larger size. These are used in flashlights nowadays a lot. It's the 18650s, and you can say these are 3000 milliamp. I believe that. They're quite a bit larger. I haven't found a use for these yet. I was planning on using them in a project, and I just never did. So they're just sitting in the case. You can't charge lithium batteries in a standard battery charger. You need to get one of these. You can buy these pretty cheap. You just charge any 3.7 volt battery. You can see it puts out 4.2 volts DC. How chargers work is they provide a higher voltage than what the battery can hold itself, which makes the electrons flow from the high potential, high voltage situation into the lower voltage situation, which is why the charge goes into the batteries. Electrons kind of behave like water. If there's a lot of pressure built up, they'll try to go to somewhere where there's less pressure. So if you have a high voltage and you connect it to something that is a lower voltage, the high voltage is going to flow into the low voltage area.